So this is a problem I'm going to ask you to do on your own. Okay, so the area of a rectangle is given by a polynomial, and the width is given by x plus 6, and you want to find an expression for the length of the rectangle. So now you know that the area is width times length. So if you were given the area and the width, you just need to divide the area by the width to get the length. And you're going to get for the length an expression, okay, involving x. So try to do that, pause the video, and come back. I'll show you the solution. Okay, so first of all, we need to do our long division to get the width. Divide by x plus 6. So x multiplied by what will give me 3x cubed. So it's going to be 3x squared. Now I multiply x plus 6 by that. I get 3x cubed plus 18x squared. I subtract. I get minus 4x squared. X times minus 4x will give me minus 4x squared. Which I'm also multiplied by 6. So I bring down the minus 23x, I subtract, and I get x plus 6, and x times 1 will give me x. So you see, I don't stop here because the degree of x plus 6 is the same as the degree of x plus 6. So the same degree, so I can keep on going. So, and actually I can fit x 1 times into x, so that get x plus 6. And of course we get a remainder of 0 here. We're expecting it, because if we don't, that means that x plus 6 times another polynomial will never give me a, and since it does, I know that it fits evenly into the area. So what I get from this is that the area is x plus 6 times 3x squared minus 4x plus 1. So the length is 3x squared minus 4x plus 1. Okay. So that's the question that we're asking us. I'm going to ask you to do something extra here. We're going to factor the area completely. So what we get here, you see, we can keep on factoring, you see, because now we knew that they were basically telling us like x plus 6 fits into the cubic polynomial a. We don't know how to factor cubic polynomials, but if we are told that x plus 6 fits into it, that it's a factor, we know we can divide by it. So when you do our long division, we're actually getting partly the factorization of our polynomial. And then we can keep going, because now, especially here, we've got a quotient that's actually a quadratic polynomial, and we know how to factor those. So we can keep on going by using the AC method. So I'm going to try to find two numbers such that the product is 3, sum is minus 4, and that's minus 3 and minus 1. Well, now I'm going to split my middle term. And factor by grouping. Oh, notice here, right? I have 3x times x minus 1. So I know I want x minus 1 to appear here as well, right? So the way to do this is to take out the minus sign. Okay. I don't want to write plus minus x plus 1, because if I do this, x minus 1 and minus x plus 1 are not exactly the same. So this is why I factor the minus sign out. Like that. And then finally I get x plus 6 times 3x minus 1, x minus 1. And that's how this polynomial gets fully factored. And it was originally, what was it again? 3x cubed plus 14x squared minus 23x plus 6. So this is how, using the division algorithm, you can factor polynomials that are beyond or higher than the degree of 2. And if we were to graph this, right, so having it factored means that we know what the it means that we know that what the x-intercepts are, right? Because if we set this equal to 0, we're going to find the let's say we want to graph, right? Graph y equals 3x cubed plus 14x squared minus 23x plus 6. Okay, now that it's factored, I have access to all of its intercepts. Okay, by that I mean the x-intercepts, right? The x-intercepts, you equate each factor to 0. So the first one you get minus 6. For the second one you get 3x minus 1. When you equate that to 0, you get 3x is 1, x is 1/3. So 1/3 0 is an x-intercept, and 1 0 is the other one. So we get 3 x-intercepts. We get the y-intercept easily just by replacing x by 0. So x equals 0 means that y is going to be, well, let's look at this here. This is easier, right? You replace all powers of x by 0, you get y is 6. So it means that 0, 6 is the y-intercept. So if we were to graph this this function, okay, we know it would go through 0, 6. 1 0 would be one of its x-intercepts. 1/3 0 would be another one. Minus 6 0 is another one. And and also we know the looking at the leading term here, we have access to the long-term behavior also. So n behavior. Okay, well, I just look at 3x cubed. 3x cubed looks like this. So we know that as x goes to infinity, y will go to infinity as well. As x goes to minus infinity, y will go to minus infinity. So we should end up here and here in the long run. So that means our graph probably looks like something like that. Something like that, okay? Well, I just want to show you that we're able to start having access to graphs of polynomials that are beyond polynomials of degree 2. Now, where's the highest point? Where's the lowest point? We don't know that yet, okay? So in calculus, it's going to be made more, this is the kind of stuff we're going to look at, like where's the maximum, where's the minimum. But at the same time, here we've got a pretty good idea already of what's going on.